So, hello everyone. 大家好. That's in Chinese. I'm from Japan. Today, I present you about a Gnuk token. That is a cryptographic USB token, which is free, implemented by free software and free hardware design. And I explain about the GnuPG scdaemon, which is a kind of a driver for the token. And this is a talk of mine, my experience to have better control. Control means by its user, not by government or not by company, and of computing for privacy with dedicated device of minimized features. And what's Gnuk? Gnuk. It's a FSIJ project, free software project and free software initiative of Japan. And implementation of it is an implementation of cryptographic token. It is a bit harder for me to pronounce it. Cryptographic token. Yeah. And it supports OpenPGP card protocol version 2 and version 3, and it runs on STM32F103. It's typo. Yes, it's ARM Cortex-M3. And it supports RSA 2048 and ECC. And somehow it works with RSA 4096, but it's so slow. It takes about 8 seconds or so to sign. And the name Gnuk comes from GNU and Gnuk, because at that time my son used to require Gnuk everywhere or every time. So this is the logo of Gnuk, and it is a software implementation. So Gnuk means the software itself, and we call a device Gnuk token when it runs Gnuk. So there are many hardware implementation, or Gnuk support multiple devices. So there are many variants of Gnuk token, actually. And sorry. This is a kind of wait a minute. So yes, this is better. This is a presentation mode. It was a printer mode. Sorry. yeah. Here it is. So this is a picture of the structure of GnuPG processes and the device. We have multiple components, software of GPG front end, and pin entry, GPG agent, and directory manager, and scdaemon, and we have a Gnuk token here. The major reason why we have many processes or software components and hardware component is that to minimize the attack surface. This is the most important point. And here, this is a typical use case of Gnuk token by concrete example of my daily hacking life. I have a computer on the go, like that. And I have a computer at work and at home. Among those three environments, I use single Gnuk token for my authentication, signing, or decryption. So it can be solved by copying a private key to each computers, but it increases attack surface. So the important things for me is no more copy of my private key on different computers. So I use single device. And it should be separate dedicated device, which is removable from computer, so that computer only supply power when it's actual use. And it should be physically smaller, so that the user can bring the token conveniently. And those are things I have learned. Controlling my own computing is getting harder and harder. You know, we have many software components these days, and we have to use, say, browser, which is so complex and extensible, and loading code from the internet. I mean, some JavaScript extensions. It is very difficult for me to control such an environment. So I wanted to control at least the computing for cryptographic operation. That is a major reason why I choose the single device only to do that. And random number generation, random number sequence is very difficult things. My tentative conclusion is that nobody should control the particular random sequence generation. Yes, this is most important part I have learned. Yes. And speaking about freedom, not only software toolchain, but also we need some free software implementation tools like KiCad, OpenOCD, Siglox, and so on. Thanks for those projects, we have a free software implementation. And we use some hardware tools. I mean the JTAG access hardware. Those firmware should be also free software. And thirdly, difficult things is that I ask manufacturer of my device. And the computer in the factory, it could be major attack vector. I mean that a malicious guy installed very malicious feature inside that computer, then all the device I asked will be suffered. So computer used in factory is also important. Yes. And the distribution of the product is also important things. Yes. And here is a small history. I started the Gnuk project in 2010, October, and with Olimex board. And then here was discovery. I discovered that evaluation board
by ST, the STM-AS Discovery Kit. It is an 8-bit computer evaluation board, but we have a USB access by STM32. And we can somehow abuse that part of the kit for GNUC. But it requires some electronics knowledge to use that part. So I supported more board by GNUC, but people requested some good reference implementation. So I designed my own FSD01 in 2011, and I asked Seed Technology for somehow mass production 1,000 pieces in 2012. And I have updated the design in 2 years ago, and I manufactured 300 in last year. And soon after it started, I found that the host side support is very much important, not only the firmware itself. And so I joined GnuPG development in 2011 to improve scdaemon. And scdaemon is access smart card through CCID reader. It is a kind of difficult software because we need to support proprietary things, proprietary card reader, proprietary cards, and some proprietary operating system, and so on. So I think that if you are a smart card user for GnuPG, you perhaps feel smart card access has been improved. And now it can support multiple tokens simultaneously if you choose in-stock driver of GnuPG. And here is a hardware design. I use KiCad for PCB design. This is done in 2011, and this is FSD01G, another one, the update version. And so lastly, I'd like to address many other things. Flashing MCU, I used to use ST-Link V2. I have to reverse engineer the protocol, USB protocol, and I wrote some tool for flashing MCU. And I need to implement random number generator. Entropy source is the ADC sample. And I need to design firmware update. And this can be the valid attack vector. We have experience in some product. Firmware update could be attack vector. And here is a difficult part. USB design requires USB vendor ID. Thanks for FSIJ, we have an official one. And the manufacturing, I depend Seed Technology in Shenzhen, and they can distribute the product too. And I have to develop my own thread library because existing RTOS, they consider more is better. But more means larger attack surface for me, so I need minimum one. And the GPL compliance issue, we need to somehow deliver source code to user and GPL itself. I
at first, I tried to put everything in the serial flash ROM within the board, but I encountered a failure because manufacturing cost matters. It takes time to make a copy if I ask factory to do that. Okay, and so I only deliver GPL itself by device. And yes, this is a mostly difficult part. How to deliver such a device? Yes, we need trust. So basically, I prefer delivering in person. But Free Software Foundation, since 2015, kindly deliver my device. Yes. And in 2 years ago, I wrote my own tool for flashing my firmware in factory. And here is source code access. And last year, I implemented USB emulation so that people can learn Gnuk without real hardware. Yes, and we have FSF, GnuPG project, Debian, and FSIJ. They support Gnuk implementation or distribution. Yes, here is a hardware suggestion for Gnuk. We can use Blue Pill. It's very cheap one, to €1 or so, less than €2. And ST-Link version 2 clone is also can be target to Gnuk token. Yes. And it is available at FSF shop. So summary is like that. Free software, not only free software, free implementation, free design and tool environment is important. But someone have to do some dirty work. That's all. So any questions? Here's a reference. So 2 or 3 minutes for questions.
We have 2 minutes for questions.
2 minutes.
What are the differences between FST01 and the recent version?
Recent version lacks serial ROM because it discontinued in 5 years. Yes, and I updated regulator because of the discontinued part. Yes.
It wasn't used anyway.
Yes. Yeah. From the software view, it's same. Yes. Okay. So, lastly, in the flight, I saw the. Sorry, I don't have later, please. I watched Blade Runner 2049, and the laser said to K, join us, please. Thank you.